All right, here's problem number 5. Let's see, the last video this is actually number 5. Here, just cross that stuff out. All right, so it says a white dwarf has a mass of 1.1 solar masses and a radius of 0.0085 solar radii. So, it's really small compared to the sun, and it's slightly more massive than our sun. And so it says it will deflect light from a distant source at what angle in arc seconds? It says to round to 2 places past the decimal. All right, so this equation right here comes from Einstein's theory of general relativity. And so it says, general relativity is a very complicated mathematical formula, but this particular result is relatively simple. Just like the Schwarzschild radius is a very simple calculation. Although you remember, this is different. All right, so this is how much light bends when it passes near a massive object of size r, and the mass has to be in solar units and r has to be in solar units, in which they are. And the 1.75 is in arc seconds. So that this gives us some angle. I call it theta here. It doesn't really matter what it is. All right, so we put these numbers into our calculator. 1.75 times 1.1 divided by 0.0075, and to round it to 2 places past the decimal gives us. So it's going to deflect at an angle of 226, and we're rounding it to 2 places past the decimal would be 0.47. Of course, it's arc seconds would be the. Anyhow, you're just going to put the 200 in Blackboard. You'd put 226.47. All right, so that's problem number 5. Let's work on problem number 6. Actually, let's take a quick look at problem number 6. Whoops, those are the formula. All right, so problem number 6 is right here. Let me highlight it. It said, what is the density of a spherical red giant envelope that has a radius of 0.71 astronomical units and a mass of 0.59 times the mass of our sun? And they give us that 1 astronomical unit is 1.5 times 10 to the 11th meters. And the mass of our sun is, of course, as it always is, 2 times 10 to the 30th kilograms. And it says here to round to 5 places past the decimal. All right, so we'll set this up. The main thing here is, know the density formula. It's just the mass of something divided by the volume. And so we have to, since this thing is spherical, you got to know that the volume of a sphere is 4 pi divided by 3 times the radius to the 3rd power. But of course, we have to convert AU into meters. All right, so we're going to do all that in just a moment. All right, so here it is this problem this is number 6. There's a little 6 right there. So we want to know the density in kilograms per cubic meter of this red giant envelope, which is spherical. It has a radius of I know I already read all this, 0.71 astronomical units. All right, so from that, you can change it into meters, right? And so to change, so 0.71 times 1.5 times 10 to the 11th, right? That's 1.5 times 10 to the 11th. I'm just using E11 here. So that becomes 1.065 e to the E11. You got to cube that and then multiply it by 4 pi divided by 3. So that's the answer in the denominator right here, approximately 5.06 times 10 to the 33rd. And then, of course, the mass, the numerator here is 0.59 times the mass of our sun. So 0.59 times 2 times 10 to the 30th gives us approximately 1.0 1/8 times 10 to the 30th. Take that number divided by the volume, and it says to round it to 5 places past the decimal. All right, so when you do it, you get something like 2.33 times 10 to the minus fourth. Let's see, is that what I got? Yeah, 2.33 times 10 to the minus fourth. And so, rounding it to, 5 places past the decimal would just be this. So it would just be, 0.00002. That's it. So that would be the density of this red giant shell. All right, let's do the last problem. All right, so here's number 7. What is the Schwarzschild radius of a star that has a mass of 0.12 times the mass of the sun, or 0.12 solar masses? So here's the equation for the Schwarzschild radius. It's a very simple equation. The only variable is the mass. A big G is the universal gravitational constant, 6.67 times 10 to the minus 11th. C is the speed of light, 3 times 10 to the 8th. Don't forget, you got to square that. And of course, 2. So here it is, worked out, 2 times big G, and here's our mass, 0.12 times the mass of our sun. Turns out to be 2.4 times 10 to the 29th, and then divided by the speed of light, gives us a Schwarzschild radius of, remember, you can always calculate the Schwarzschild radius. It doesn't mean that this star is ever going to become a black hole. All right, so anyhow, it is, we're going to round to 1 place past the decimal. It would be 300 and, oops, I messed that up. Oops, let me erase, sorry, I messed that up. 355, all right, 355.7. We'll just round it to 1 place past the decimal. And of course that would be the number that you put in Blackboard, and of course the answer is in meters. All right, so all right, so those are the review problems. They are exactly like the problems on with different numbers, of course, on test 3. And of course, you're going to see these again on the final as well. All right, so watch these 2 videos as much as you need to make sure you know how to do these problems. And good luck on the on test 3. And of course, good luck on the final as well.